Hi everyone, my name is Thomas Kim. Today is February 7th, 2019. In this episode, we will learn the most important yet most incorrectly used feature in C++ language. That is, how to make best use of C++ exception. More specifically, we will implement for each permutation algorithm, and through this algorithm, depth first search, breadth first search, also kill bounding function or bounding constraints. We will learn these things in this session. This session is based on my previous video, the most important yet least understood concept in C++ language. Please double click this link. If you haven't watched this video, please watch it, because this session is based on my previous session, the most important yet least understood concept in C++ language. Please download our previous source code by clicking this link. Also, for more information about the algorithms that we address or deal with in this session, please double click this link. Please watch this video very carefully. We will develop very powerful algorithm based on this video. Okay, let's get started. This is the source code of our previous session. We will create a new file for each permutation, CPP. We will copy the code from our previous session and we will modify it a little bit. Now I will change this function name. This is our previous code. I will change this function name for each permutation. Constant set t element type L, size t R. I will introduce two more type name, operation type name, PALAM types. Then here, operation type, operation, PALAM types, PALAMs. Now here, because we are passing L through this parameter, we don't need this. Then we still need to reserve R. Then we are passing permutation L, R. Now we are passing R, size also. Then std forward. We are forwarding operation, then std forward parameter types, PALAMs, like this, modify like this. Then we don't need this. So it's not returning anything, it's returning just void. This is good enough. Now we need to modify this type, this here R. This is our previous function, size tr. We also need to introduce two more parameters, type name, operation type name, PARAM types. Then operation type, operation PARAM types, PARAMs. With this, we will first modify, we will modify here. Before calling permutation here, we call operation. We are passing this parameter L, R, then parameter. We are forwarding L, R, std, forward PARAM types, PARAMs, like this. We modified this part. Since we also passed R here, R, here we are returning like this. After calling, if R equals 0, then we return. This is null, void. So return. When R is 0, then we return. Now let's try how to use this function. We are calling this function like this now. This is modified. I modify like this. Okay, I will create permu set t int. It can be anything. L 0 1 2 3. We are creating a set here. Then we don't need this. We pass first parameter is permutation set L. Then we can set L size. L size like this. Then we are passing function. We will create a function. We can create here or anywhere. We will just create here. Auto DFS. DFS means depth first search. DFS for depth first search. We are creating a closure, lambda closure here. Permu set t int constant. We will get L constant permu set t int r. We can send any parameter, but I will just do this. Then here for auto constant e in L talk permu out e like this. I will copy once again. This is R. Then I copy this part once again. Permu NL. I copy, paste like this. Now we are passing this function like this. Let's see. This is function main. This is auto. We are passing this function. Now let's build and see. dir cl ehsc for each permutation cpp f mexe. Let me see. Sorry, we have to fix here like this. std forward operation type operation, and here one more std forward PALAM types PALAMs. We fixed the one here. Also, I think I made a mistake here. I fixed, then I have to put it here. If r equals 0, then return. Else I modified like this. And let's fix one more. I don't think I need new line here. I modified. Let's see. Okay, now let's try to build once again. This is GNU compiler. Wow, popping again. Let's remove wow popping again. This. We delete this part. There's something wrong. Sorry, we have to pass copy. We passed wrong here. We have to copy this. Now build again. Wow, it works. 0 is moved, 1 is moved, and 2 is moved. So 0, 1. Now all 1, 2, 3 is moved like this. So we are visiting all elements one by one, all permutation. This is called depth search first. Now we can increase this element count 4, 5. Then let's build once again. All permutation is displayed, all process is displayed, how each node is visited. We can try with Microsoft compiler, CLS. So if we scroll up, we can see how the permutation is processed. This is called depth first search. We just implement the depth first search. We can also implement breadth first search. Good morning everyone. The first part of this video I filmed last night, and while filming last night I felt very tired and feel sleepy. So I had a good sleep last night and I just got up and watched the video clip that I made last night, and I found there is a few flaws in my video last night. I will fix that first, and I will also clean up some part of this code that is unnecessary in this session. Please note that I prepared this enum permu function for enumeration of permutation just for demonstration purpose. This algorithm is not much efficient. I will show you, or I will provide you more efficient algorithm in some future sessions. This is just for demonstration purpose. Also understand how to enumerate permutation. I will clean up the code. I will remove all comments to make room to make shorter this code. Okay, so I will remove this part, and I will also remove this part. and we are not using this code, so I removed, and I will also clean up, but this part we use, so I will leave it, and we need this. And now I will remove comments because I want to show you the whole code in one screen, like this. Sorry. Okay, then I will also remove this like this, and I will still make it shorter to make room. This is to help you see the whole function in easier. And I will also make it into a single line of code, and I will also remove this part, remove this comment into a single line of code, and remove this, remove space like this. Can you see the whole function now? From permu too small, character size too small. So I will fix this part. I made a mistake here. I will fix like this. Or okay, I fixed like this, and I will remove run. So you can see the whole function. And I think we don't need this any longer. We don't need this set. I will remove this part, this, because we are not generating permutation any longer. We are visiting each node, and we cannot use this part. I will make it like this, and we don't need this. I will delete it, and now we can see the whole function. Not yet. I will move it like this, and I will make it shorter too. Okay, this is emun permu function. I removed here one parameter, so I also need to fix here. We don't use it any longer, and we don't need it. Let's see. We also have to fix it here because we deleted this parameter. We delete, and we have to put R here. I have to remove, so we are shrinking. We have to -1. Okay, this part is important. I will show you why. Okay. Now let's build once again. I think everything is done. Also, I will remind you, we can do this, but it's very ugly and it does not extend well. So I will change just auto. And we will modify this part. This part is not good. It's copying. Okay, so I will say auto reference. It's easier. Then, okay, let's build once again. The reason I made it like this shorter is to show you all this function in one screen. F11 to see the whole function. Now let's build this function once again. Okay, it works as before. So I will make it smaller. It's too big. We will test just 4 elements. CLS M. Okay, the last index, the last permutation works correctly. Then we examine the first permutation. So this is depth first search. Okay, this is depth first search. Before breadth first search, I will show you how to take advantage of this R, parameter R. This is R number of choices, R of L size elements. Okay, I will explain how to use this parameter R. And before doing that, please note that we are calling this function recursively. I will say visit each permutation. I will modify the function name like this. Then I have to modify this also. And I will change else here. And to make it clear, I will say return. Okay, this is just for in case R is 0 or L is empty. Then here when set is L is empty or R is 0, actually we don't need to call this function. When R is 0, we already called this operation function, and this function will not enter here actually, but also in this case we already called this function, so we don't need to test this case. When R minus 1 is 0 or the set of copied L is empty, we don't need to call this function again because it's very expensive. Okay, please watch it carefully. If R minus 1 equals 0, it amounts to this part, or this copied L size is empty, then we don't need to call this function. So I will modify like this. Now, do you understand this code? Let's check. 1, 2. Okay, this is to prevent unnecessary recursive calls. Okay, please understand this part. Now I will show you how to use this parameter R. Since we have 1, 2, 3, 4 elements, or we can have 5, 6 elements. Okay, we first enumerate first 3 elements only. Then we can provide here 3. We are just enumerating, making permutation, and it is like this. 5 P3. This is like this. This parameter. This R3. 1, 2, 3, 4, 5, 6. This is 6 element. Okay. This parameter amounts to this R. Now let's build. Sorry, we changed the function name. This each permutation. Okay, so I have to modify it here too. CLS. Please note that this is the set of R. This is the set of R, the permutation. Only 3 elements are chosen. Okay, just only 3 elements are chosen. Now we implement breadth first search. About breadth first search, BFS or branch and bound search, please refer to this video. It's very important technique for advanced algorithm. To implement that, we will introduce enumeration here. enum class depth first search or breadth first search, like this. Depth first search or breadth first search. Default is depth first search. Breadth first search, like this. We defined an enumeration here. Now we passed DFS as parameter. I copied this. I passed parameter here. After size R, I say visit method. Okay, I introduce new parameter. Then I pass copy. Because this is recursive function call, we also have to provide here this parameter. Okay, I pass this parameter because this is recursive function call. And in this function, if beast method is DFS BFS breadth search, depth search, this is depth search, we are always calling this function. Else means beast method is breadth first search. We copy this function. We only call if L is empty. L size L empty. Okay. We call operation when breadth first search method. We call our function only when L, no, I have to fix like this. Only when R equals R minus 1 is 0. Only in this case. Only in this case. Okay? Only when R minus 1 is 0. Understanding this concept is important. We will test it soon. Right now. So here we also need this parameter. I copied it and paste it. Node visiting method. And we also have to modify this. Oh, we can pass parameter here. We also have to pass here. If visiting method equals DFS BFS depth first search, then we call this function. Else means visiting method is breadth first search. In this case, for size T n equals 1 and less than or equal to R plus n, then we are calling like this. Here, instead of R, we are passing n. Okay? Now here, we are testing, I will say it handler DFS BFS handler BFS for breadth first search. So we are modifying this, and before we will just say L size, and it's too big. I will make it 4 elements. Permu BFS. We will test depth first search first because we modified. This is the previous state. We will fix it soon. This should run as before. This is depth first search. Okay, this is depth first search. I will copy it. If you don't like this syntax, then we can do like this. This is type. Okay, this type. So we are using beast method. Permu DFS like this. I say VM visiting method, visit method, VM. Okay. Then I copied this like this. and I also changed like this. Okay, Breadth's first search. Now we are trying it. CLS. Wow, this is Breadth's first search. For each node, first permutation, just a single, we are choosing just one element. Then this is second depth, second level load. This is third level load. This is first level load. So everything works fine. Okay, I will change it like this. Depth, first search method. This is Breadth's first search method. About these two methods, please refer to this YouTube video. About this, please watch this video. Now we will implement kill bounding function or bound constraints. About kill bounding function or bound constraints, please click this link. Then this link will lead you this YouTube video. Understanding kill bounding function or bounding constraint is important for advanced algorithm. Now I introduce one more enumeration and one exception. enum class permu combi operation. Default is keep going. Execute as normal. Kill branch. Do not visit lower level branch. Stop processing. Exit the visit each permutation or visit each combination function. Then I introduce an exception. So I introduce exception like this. Class permu combi exception, public std exception, like this. Now let's think about the kill branch. Its return value is permu combi operation. I copied. Here I declare permu combi operation return value. We will default it keep going. We initialize like this. Actually this is default value. So here we catch the return value of our operation. Also here we catch the return value of our operation. Then the return value, this value, I will put it here, is equal to keep going. It should be end like this. We keep processing as normal. I hope you understand this concept. If it returns something else, if our operation function returns something else, then it doesn't execute. Okay? If operation return value equals permu combi operation kill branch, we continue. We do not visit lower level branch. We move to next branch. Else, if I will say if. This part is very important. Stop processing. Note that we are in deep recursive function calls. How can we stop processing this function? The answer is exception. We throw permu combi exception. We throw. Then all operation ends, stops. Okay. Then I copy this exception. We should not catch exception here. We should catch exception in this level. Try. Catch. Like this. It's just a dummy. This exception is dummy, so we don't need to catch. We don't need parameter. This is good enough. Now we are returning value. From this function we are returning value. Okay? So we have 4 elements of permutation set. I will disable this part. And here, if R0 is divisible by 2, it means even number. The first number of permutation start with even number, then return permu combi operation, kill branch. Okay? Else, here, then we return permu combi operation, keep going. We modified like this. Please note that we are in breadth first search. Now we compile. Now see, this is breadth first search. 1 3 1 3 1 3. Only odd number, only permutation that starts with odd numbers are displayed, executed here. All other branches, all even branches are killed. All even branch, or all permutations that starts with even number are filtered out. Now we change it to depth first search. Please compare this. I will name it, I will recompile, name it breadth. Then I disable it. Then enable this part. And change the executed file name depth depth. Now m depth. This is depth first search. All permutations that starts with even number is filtered out. This is the power of this algorithm. Okay, so the reason this function beast each permutation works properly is that we designed it exception safe way. We designed it in an exception safe way. If we haven't prepared this way, this doesn't work. Now let's consider about return type. I will add here one more beast and node. I added this. I copy. I will modify here or end node. I will copy this part. I have to prepend like this. I added one more visiting method, and we don't need to change anything. We don't need to change anything. So it should work properly. With this, we will create another function. Now we are learning how to return values. I copied here. I will change like this. Extract permutations. And I don't need this. We are not displaying, we are extracting. Here, set of sets. This is int, permutations. I created an empty permutation here. There is two way or three way. There are three ways to return values in C++ programming. I will use one method. We are capturing. This is the first method, capture. Method 1, capture, through capture, lambda capture. Then here, permutations. I will make it more visible. In place, back or push back, R. Then we just proceed. Okay. Now I will use this. Here I will create another one. I will disable this part. Extract permutations. Now we are passing this lambda. Okay. Also this should be beast and node. With this, for auto p permutations. Auto e p permu cout e permu cout permu and there. Now let's run this function. We are extracting all permutations like this. I will rename it extract. Now why it is calling? Sorry, we have to modify. This is correct. This is correct. What is wrong is here. We say if L size L empty, then we do this. We modify it like this. M extract. So it's working properly. We need to give one more line break like this. CLS M extract. Now we extracted all permutations through this set. Okay, this is all permutations. We can have lots of complex way to program. There is a second method. I will create a second method to extract value. I will say through capture, and I name it through capture. This is through capture method. This is through parameter, through PARAM. In this case, auto are permutation. Now we are not passing this permutation, we are passing as argument like this. Then I have to say permutations. Now we are calling this function. This is second method through lambda argument passing. Now here through capture, I will disable this part. I will first copy and disable for your reference later. I disabled. This is now through parameter capture like this. Now we have to provide, important point is here, we have to provide this parameter, this. Okay, we copy, we have to provide parameter, don't forget this, then it all works. Now parameter, I will say PARAM. Now we are passing parameter. What's wrong? Oh, I misspelled. Oh, I can say peas. I just say peas. I misspelled here. Peas, like this. I just changed like this. This is argument. Then here, okay, CLS M PARAM. Now it works the same way. We are passing parameters. Here, this is parameter. We can pass any parameter. I think there is some missing point. Some loose end. I will fix that. Here is some missing points. I will copy this, paste, else if beast end node, then we have to fix like this. We have to copy, and this should be modified like this. Beast method, beast end node method, we call function only when this is correct. And also it should be Bread's first search. I fixed this. Then try again. Okay, it now works perfectly. Also, let's fix. Now we don't need this. We don't need this. Because in this case, we are visiting end node. This should suffice. Also this one. We should not need this. Because this is also the case, we are visiting end node. Let's try once again. M PARAM. Also, okay, it works. We disable this part and we enable this part. So this should also work in this case. I say PARAM through capture. Capture. M capture. Okay, it works. Sadly, I don't like beast end node. full node only. I will change it into full node only. Full node only. I modified this, then I change full node only. Now try once again. Okay, it fixed. Capture. Also, there is one thing missing. This full node only works properly. Depth first search works properly, but breadth first search it is inefficient. The implementation for this search method is inefficient. We will improve it in future sessions. Our current implementation for each permutation, this algorithm is far from being efficient. This session is mainly concerned to help you understand the algorithm about how to implement permutations and also combinations. In future sessions in production level code, we will turn this into loop-based permutation such that we can take full advantage of hardware computing resources. I am planning to implement most advanced algorithms in manageable and easier to understand manner into complete libraries such that anybody who has some basic understanding about algorithm can take advantage of or can best use of my algorithm libraries. Please subscribe to my YouTube channel. Thank you for watching.